Section 4.6 continued. Last two trig functions that we're going to look at the graphs of are tangent graphs and cotangent graphs. We're going to list the same information that we do for sine and cosine graphs to begin. So our amplitude is 1. The first major difference between tangent and cotangent graphs compared to the sine and cosine and therefore secant and cosecant graphs is that the normal period or standard period of a tangent and cotangent graph is pi radians. So our period is going to now be pi over the lead coefficient, so pi over 1, which is just pi. Our increment then, instead of being 1/4 of the period, is going to be 1/2 of the period. So pi over 2. Phase shift, we're starting at 0. Center line is also at 0. So now when we go to graph this, our critical points are at pi over 2, pi, 3 pi over 2, 2 pi. Amplitude is 1, and the amplitude isn't really going to do a lot to your graphs. It just controls how quickly the tangent graph is going to approach certain asymptote lines, which we'll talk about here in a second. Okay, so those are the values that we have. Now, to get our original tangent graph, just like when we first did our sine and cosine graphs, we related it back to the unit circle. Once we did that, we noted that all sine graphs start on the center line. If it's positive, it goes up, negative, it goes down, and so on. If it was a cosine graph, we went to the unit circle, we got our original graph, and then we noted that all cosine graphs start above or below the center line. If it's positive, above. If it's negative, below. We're going to do the same thing here with tangent and cotangent, but to do that, we first need to relate it back to the unit circle. So let's go back to our unit circle. We have our points at 1, 0, 0, 1, negative 1, 0, and 0, negative 1. From here, tangent we know is sine over cosine. So start at 0. Sine value over cosine value. 0 over 1 is 0. So I have a point here. At pi over 2, sine over cosine is undefined. What do we do when something's undefined? Put in an asymptote line. At pi, sine over cosine, 0 over negative 1. Back at 0. 3 pi over 2, sine over cosine, negative 1 over 0, undefined. And at 2 pi, we are back at 0. From here, we need to know what our graph is going to look like in each quadrant between 0 and pi over 2. So as we go through quadrant 1, what do we know about tangent? It has to be positive. So our tangent graph is going to have to be up here approaching this asymptote line because we know tangent is positive between 0 and pi over 2. We get into quadrant 2. All students take calculus. Tangent becomes negative. So between pi over 2 and pi, our tangent graph is negative. So it looks like that. Between pi and 3 pi over 2, all students take tangent is positive in quadrant 3, so it's going to cross here, approach the asymptote line here. And in quadrant 4, tangent again becomes negative, approaching the asymptote line here. So there's our tangent graph. And now there are some things that we know is true about all tangent graphs. First thing is positive tangent graphs fall left and rise right as they did here. So that means negative tangent graphs are going to be just the opposite. Fall right and rise left. And the third property that's important is being able to identify where your asymptote lines are. Asymptote lines will always be at the first and third critical value after the starting point. After the phase shift or starting point, however you want to think about it. So our starting point was here. The first point and third point after is going to be where our asymptote lines are. Remember, asymptote lines will always be at every other one. So if you know it's at the first point, then you know it's got to be at the third point, fifth point, seventh point, ninth point, depending on how far out you carry your graph. Okay, looking at our cotangent graph. Okay, starting with amplitude. 1. Period, remember, of tangent and cotangent is just pi. Increment then is only half of the period. Phase shift, there is none, so it's x equals 0. Centerline shift, there is none, so it's y equals 0. Critical points are at 0, pi over 2, pi, 3 pi over 2, and 2 pi. Amplitude is 1, so our graph's going to go up to 1, down to -1. Now use your unit circle. Cotangent, we know, is cosine over sine is a quotient identity. So starting at 0, cosine over sine is undefined. So we're going to have an asymptote line at 0. At pi over 2, cosine over sine, 0 over 1 is 0. At pi, cosine over sine, -1 over 0, undefined. 3 pi over 2, cosine over sine, 0 over -1 is 0. And 2 pi cosine over sine, again, is undefined. So you can see the same type of pattern as what we have in the cosine graph. Every other one is an intercept, and the ones that aren't intercepts become asymptote lines. Cotangent through quadrant 1 is positive. Quadrant 2 becomes negative. Quadrant 3 is positive. Quadrant 4 becomes negative. So there's our graph, and you can see some similarities between the two graphs. Asymptote lines at every other one. You can see that they both have the same shapes, but notice cotangent graph rises left and falls right, so it's just the opposite of what happens in our tangent graphs. So things that will be true for every cotangent graph. Positive cotangent graphs rise left and fall right, which means negative cotangent graphs fall left and rise right. And the last thing, asymptote lines are at the phase shift and every other critical point after. So those are general rules that you should know about tangent and cotangent graphs. Tangent graphs, when they're positive, fall left, rise right. Cotangent graphs, when they're positive, rise left and fall right. And when they are each negative, the shape looks like each other. So remember the difference in asymptote lines. For a tangent graph, first critical point after the phase shift. For a cotangent graph, asymptote line at the phase shift. So looking at our first graph here, y equals tangent of x over 2. Amplitude is 1. Period pi over the lead coefficient. Increment half the period. Phase shift, there is none, so x equals 0. Center line shift, y equals 0. Setting up our graph here then. Phase shift is 0, increment is pi, so 0 plus pi, pi plus pi, 2 pi plus pi, and 3 pi plus pi. Amplitude is 1. This is a tangent graph. Tangent graphs have asymptote lines at every other critical point starting at the first one after the phase shift. So at pi, 3 pi, we are going to have asymptote lines. The other critical values are going to be where the tangent graph is crossing the x-axis. It's a positive tangent graph, so it rises to the right, falls to the left. And there's our graph. The only thing that the amplitude controls here in our graph is how quickly this graph approaches the asymptote line. So don't worry about that. Just draw the general shapes. Make sure you still label your amplitudes, but you're not really going to differentiate between an amplitude of 1 and 2 very easily from your graph. Letter B. Y equals -3 tangent of 2x. Start by listing all the information you need to. Amplitude is 3. Period, 2 pi, pi over the lead coefficient, which is just pi over 2. Increment, half of the period, which is pi over 4. Phase shift, there is none, so x equals 0. And center line shift is y equals 0. Increment pi over 4, 2 pi over 4, 3 pi over 4, and 4 pi over 4. Amplitude is 3. We're again dealing with a tangent graph, so we know our asymptote lines are going to be at the first critical point after our phase shift and the third one. Other critical points are going to become where our graph crosses. This time it is a negative tangent graph, so it's going to have the opposite behavior left and right. This time it's going to fall right and rise to the left. Last one, C. Y equals 1/4 cotangent of x plus pi. Amplitude, 1/4. Period, pi over 1, which is pi. Increment, 1/2 of the period. Phase shift, we're going to set x plus pi equal to 0 and solve. So our starting point's at negative pi. Center line is still y equals 0. So we have a phase shift, so I'm not going to put in my y-axis yet. Starting point is shifted to negative pi. And I'm going to add that increment value of pi over 2. So negative pi over 2, 0, positive pi over 2, and pi. So there's our y-axis, which is a critical point this time. Amplitude of 1/4. We're dealing with a cotangent graph. A cotangent graph has asymptotes at the phase shift or starting point value, and every other one thereafter. So there's our asymptote lines. Our other critical points become where it crosses the x-axis. It's a positive cotangent graph, so it's going to rise left and fall right.